So we thought it would be interesting to give you some insight into Joe on this special occasion through the eyes of his students. So we've assembled here a large crowd of former students, and so let me begin. Eric mentioned this morning that he was given a horrifying first draft of Joe's book early on in his career, and managed to survive nevertheless. But I actually had the benefit of getting sort of the zeroth draft of the book. My second year as a grad student, Joe taught his string theory course for the first time, and of course that was great. He had very detailed lecture notes, and which of course eventually turned into the book. But that came along, of course, with a couple of lectures every week for the entire year, and obviously I learned a lot from that experience, and worked all the problems and bugged him in his office every week, and that's how I got to know Joe. So one of the first questions he actually asked me as a grad student after the class was over and I had gotten far enough along was to think about what T-duality did in open string theory. And of course, it's a very simple but important question. And so one of the things that I had certainly been prepared to do, having taken Joe's course, was to compute string amplitudes. And man, I could normalize a vertex operator too. And so that was good enough to compute things like the tension of a D-brane. And I guess you know the rest of the story. But anyway, so just to finish up, since we have so many people, one of the things that I really valued about the way that Joe approached his students, or at least in my case, maybe other people will have other experiences, was that I actually only wrote that one paper with him as a grad student, and he was completely open to the idea of me going off and working with Willie or working with postdocs and for the rest of my graduate career. And I can certainly see in myself many of the things that I, as I interact with my own students, things that I learned from Joe as sort of a role model. So thank you, Joe, and I certainly wish you the happiest birthday. George.
Why don't we start with Mariana here, now go to Santa Barbara student from Austin. From Austin to Santa Barbara.
Okay. Well, I can, 1 minute, 2 minutes. I had a similar experience as Henriette. When I decided I wanted to do string theory, then I came as a prospective student to many universities, and I was told, okay, fine, stand in line, there are 50 students ahead of you. maybe in 3 years we'll see where you are, how you've done. And then I came here, and then Joe talked to me, and he said, well, you want to do string theory, that's great, you can come, you can take a course, a string theory course, you can do a reading course with me, and then we'll see. So I said, well, great. So I came here. Then, well, it turned out that year, twice as many people as usual came, and half of them wanted to work with Joe, so it wasn't that easy. But, well, we had a reading course, and then at the end of the course, so sort of toward the end of the course, he said, I had a problem for you. And I said, well, great. That means he's taking me as a student. And so what's the problem? And he said, well, we're doing this with Matt Strassler. There's we are perturbing ADS 5 times S5 with 3-form flux. And I know it's supersymmetric, but it would be good to check that it's supersymmetric. And I said, wow, that sounds hard and boring. And actually, it turned out to be completely the opposite. I mean, it wasn't trivial, but with Joe's guidance, nothing is hard. And I had so much fun that I'm still doing that in part today. And so, well, thank you, Joe, for not discouraging me at the beginning, for giving me this good problem, for all the guidance. also after the PhD, all the support, the letters. I wouldn't be here if it wasn't for you. And thank you. And well, just to finish, one secret that very few people know about Joe. He's only 59. And he will be 59 for a little time, so I'm not saying happy birthday.
So Rob, why don't we go, maybe Andrew can continue, or go one side and the other. Thanks.
Well, I had the good fortune to be here at the same time as Mariana, and I think Joe was feeling a little overwhelmed with all of the students that he had to take on to sort of support the department. But I feel very lucky I got to work with you. I go a little opposite direction, something people have been saying all day, that when Joe wrote something in a paper or explained something, it always seemed very clear afterwards. And I think all of us using your book, sort of when it first came out, found that to be true. And then we went to try to go do the homework problems. And we realized we didn't always understand quite as well as we thought. But that didn't make the explanations any worse. Working through it was always what taught us the most. And I think just to add to what people said, is the questions that you asked also helped us learn a lot. And also to not be afraid of working on the hard problems. I know I'm still working on some that you suggested to me 14, 15 years ago now. Getting close to solving some of them. But thanks.
Okay, maybe we can continue here with Eric.
Oh, hi. I thought it offered a slightly different perspective because I'm not doing physics anymore. And I thought it'd be interesting to think about kind of what the lessons are for somebody who isn't doing physics, those of you who have students and go off and do other things. What do they learn from doing physics? How does computing partition functions for K3 orientifolds prepare you for the world? I was faced with the same problem. My 6-year-old teacher said, "Why don't you come in and tell us something about physics?" And I was like, what am I going to tell 6-year-olds about this kinds of stuff? But it came to me the other day that the most important part, it comes down to a word, pertinence. It's to me, being a physicist and applying that mindset outside is really learning how to kind of cut the chaff and think about what's important, what's relevant in a problem or in a situation, and move the other stuff away. And I had this experience working with Joe. I was so proud of myself. We figured out this technical problem, and that the D branes had to be paired in a symplectic pair. And he said, "Okay, well, you go write draft." So I wrote the draft. I had the calculation. Everything was there. And then he took the draft. It took forever to get back to me. And then he heard that these guys at Rutgers were doing something similar. Suddenly he accelerated his pace. And I got this paper back, and it looked nothing like what I'd written. It was much more interesting. And that's when I really learned, okay, the calculations are important, but you really have to think about, what it all means and how to fit it into a larger context.
Thanks, Eric. Should we continue with Joseph? Yeah.
So I just want to give a few things in my history. So I came into string theory actually after doing cosmology. I used to do cosmology with Alan Guth at MIT. So I applied to grad schools hoping to do cosmology. And then right before visiting grad schools in California, I came to Stanford. And I talked to André Linde. And he told me, he put my hierarchy straight, because I was really hoping cosmology was this big thing in my brain, and string theory was somewhere. And André Linde told me, look, if you come to Stanford, everybody who comes to Stanford tries to work with Lenny. If they cannot work with Lenny, they go to work with my wife, with Renata. If they cannot work with Renata, they go to work with me. If they cannot work with me, they go to work with Dimopoulos. And if they cannot work with Dimopoulos, they send them over to Slack to do phenomenology with Michael Peskin. So this is the hierarchy which André Linde gave me. And of course, as a cosmologist, he put himself, number 3 in the hierarchy. And I was like, maybe there's something in the string theory. Why is everybody trying to do that? And then I came to Santa Barbara, and I came to Joe's office, and I had no idea about string theory. I was at MIT, there's a complete blockade against string theory. I had no idea about, deep brain, Strominger of Alpha, all these things are like, you could have talk Chinese. Nobody knew anything. And, I was one of the good students there, at least that's what I like to think. But there's a complete blockade, and, I came here, and then I came to Joe's office, and he was like, oh, I just calculated this thing. I calculated it in some of these theories in heterotic, and, I got some result, and then I calculated in some other theory, and I got the same result. It's a completely different calculation, and the two results matched. And I was like, wow, this is the thing to do. So, I really so I just decided to, completely give up cosmology, and, just, start fresh into string theory. I remember Joe told me that, I asked him, why don't you do, string cosmology? This is, way before KKLD and all these developments. And he said, cosmology is not really well on firm grounds, and, string theory is not really too much on firm grounds, and, if you put them together, it's too shaky for my taste. So, and then after I left, of course, he goes and does cosmology. And he did the same with the beta ansatz. I remember we were doing integrability, and then he said, I'll never work on this beta ansatz. If you want to learn about the beta ansatz, feel free, talk to Nick Reed and talk to, all these people who do integrability. And then, after I left, he starts doing beta ansatz. So I had this. The other thing which I wanted to say in completion to what Matt Strassler said, I think all of us had this experience of, working on a project with Joe, and then, being completely impressed by the depth he had, and then really understanding all the details of this thing. For Mariana, this was about flux compactifications. For Andrew, this is about string cosmology. For me, it was about Polchinski Strassler. It's really like, this paper, you keep on reading it, and, you find more and more pieces of physics, and I just, it's just hard to realize how much physics is there. And this inspired me actually on two directions. First of all, according to what Joe told Paul Maldacen about the deep brains being at the horizon, he said, you cannot put deep brains at the horizon because they fall in. Well, Polchinski Strassler stuff doesn't fall in. Polchinski Strassler brains, they have a mass which goes like 1/G string. They are big. They have black hole size. They can stay at the black hole horizon, without falling in. It's really like this physics which Joe really spelled out that the mass of these guys, the size of these guys grows when you increase G string. This is really what makes all these constructions of black hole microstates work. So this is, he's responsible for that. And another thing which he's responsible, which, Mariana and I are doing right now is, the fate of anti-brains in Klebanov-Strassler. If you look anti-brains in Klebanov-Strassler and you look at them, at the North Pole, it looks like Polchinski-Strassler. So again, I got, all my Polchinski-Strassler, a few months ago when I realized that, I got all my Polchinski-Strassler papers out, and, I started, computing all these coefficients, and, 2,1 and 3,0 and so on and so forth. And we found that, these anti-brains are, they have a tachyon on their word volume. So it's really like, Polchinski-Strassler can really, yield out, this really cool pieces of physics. And all my postdocs and everybody in Saclay are looking at this as like, wow, how did this guy do it? You have some form which is closed and co-closed and constant, and, it's just, amazing, amazing piece of physics after amazing piece of physics, every once in a while, just, jaw dropping. So I'm just, having this experience, almost, 10 years after the fact, and I'm still getting impressed by this, by what's there, and, it's something which, is really influencing the way I think about physics. So, thank you so much for all this.
I don't know about you, but I'm exhausted.
Let's okay, Naila, maybe you change your pace.
So I'm going to try to follow that. I wanted to just tell a silly story of no particular import, if you will allow.
Please speak faster.
It's okay.
At one point, during the years that I was in Santa Barbara working for Joe, he became interested in cosmic strings. And I remember at one point he was preparing for giving a talk, a public talk, or maybe it was a colloquium on the subject of cosmic strings, and he came by my office. I had a toy Halloween whip in my office, and he wanted to borrow it to give his public talk as a demo. And of course, I said, of course, yes, of course. And then I realized my great flaw in the logic there. I then had an advisor armed with a whip. And he loved that whip. I don't think he ever actually used it on a person, but he wasn't above cracking it in my ear to startle me while I was working in my office. It is a true fact. On a more serious note, I said that I never worked on cosmic strings, and that's the truth. And it's actually rather interesting. When I first started working with Joe, when I met with him and I went into his office, one of the first questions he asked me was, "What are you interested in?" He wanted me to decide what I wanted to pursue as a graduate student, and he was more than happy to follow along and to find an interesting and a deep question related to what I was interested in, and to learn along with me and to pursue that. And I really think that that's quite extraordinary and not necessarily something that everybody gets as a graduate student. In my own life, I'm now working at a liberal arts college where mentoring undergraduates doing research is a big part of my life. And I've learned that probably the best thing I could do is to try to emulate Joe in this, to listen to all of their ideas and to listen to what they're interested in, and to try to find a good, deep question somewhere in their excitement to drive the project. So thank you, Joe, and happy birthday.
Thank you. Ahmed, maybe?
Thanks. It's working? Yes. So in contrast to all the other speakers, I'm actually still a student of Joe. So I should be careful with my words if I want to graduate. So that's the first thing. Second is, let me start again. So hello, everyone. My name is Ahmed, and I'm addicted to Joe. And
Hello, Ahmed.
And I'm happy to see all my fellow panelists who are all ex-addicts of Joe, and they seem to have moved on. They're still addicts. Oh boy. And just to prove how addicted I am to Joe, I see physics differently. And I usually do physics by imagining things, but now Joe is everywhere in my imagination. For his first seminal work on renormalization, this is what I see when I read that paper. So Joe running the RG.
Running RG. Hello.
And for the other one, this is actually quite disturbing. So if you're below a certain age, maybe you should step out just for a few minutes. This is how I look at his D-brain paper. And and as a graduate student, one tends to idolize their advisors. And as you can see, so at least for my case, I tend to imitate Joe in a lot of things. Every now and then, it would come out in my speech. I would imitate him in my speech. I would imitate him in my speech. For those that know, Joe repeats his sentences quite a lot. And now, whenever I sit in talks, I sit restless. I bend down, and every time I think I understand something, I go, And slowly my hand would cover my eyes as well and do that as well. You guys know that? Yeah. That's Joe. And I've also developed a new favorite word, which is good.
Good.
Yes, and another thing, my doctor told me to stay away from, which is not to touch my scalp anymore, because I've picked up this new way of scratching my head every time I feel an itch, which goes something like. Which Joe is famous for. And I mean, picking up habits is nice. You remember your advisor, later in your years. But it would be awesome if I was to pick up some of the better ones, like revolutionizing physics every now and then. So I have a few months left, so I hope to pick that up from Joe. And so more seriously, Joe has been. It has been very wonderful to work with him, and I stress to work with him not work for him. This is something that I really appreciate in Joe, in that he really made me feel that I'm working with him and not for him. And just to end, this is a story this is an incident that happened to me that made me decide to work with Joe, or at least it was the ceiling factor. I bumped into a theoretical physicist off campus. He's actually not here. And I was telling him to give me some advice. And I said, I want you to remember back to your graduate years and to tell me, what is that one piece of advice that you would have wished somebody had told you? And he looks at me in the eyes and says, work with Joe. And with that, I thank you, Joe, for everything. And I will also follow the tradition of Mariana and not say happy birthday until your actual birthday.
All right. Maybe we continue on this side with Makoto.
Yeah. I'm Makoto Natsume from KK. I was a last student of Joe at Texas. When he moved here, I also moved here and spent a wonderful 2 years. I was waiting for this occasion for 20 years to tell you funny stories of Joe, but this is still a scientific session and it is recorded, right? So instead, I want to tell you how great Joe is as a teacher. You know, Joe is often ahead of us for many years. He somehow foresees future development. Just to remind you, deep brain was discovered 6 years before the second string revolution. And he has been interested in high TC superconductivity and non-Fermi liquids since early 90s. And now, many of us, including me, study the issue using ADS-CFT. There are many examples like that. And I want to tell you my own example, which is about my first project. My first project was so-called effective string theory proposed by Joe and Andy Strominger. I will not explain the details, but effective string theory tried to solve old problem, how string theory is related to QCD. String theory looks similar to QCD, but the critical dimension is 10 or 26 instead of 4. You know how to solve this problem now using ADS-CFT, but this is a story of early 90s, and we needed 6 more years. I will not tell you the details of my project, but I tell you the key idea of my project. It was actually Joe's remark. One day, Joe told me, Makoto, string theory which describes QCD must live in a curved spacetime with 4-dimensional Poincare invariance. This is the key of my project and sounds pretty much like ADS-CFT. You know, 5-dimensional ADS is a curved spacetime is 4-dimensional Poincare invariance, actually with more symmetries. Of course, we were still far away from ADS-CFT. ADS-CFT needs great insight by Huang and GKP Witten. Also, you'd say the idea is pretty much obvious from the work of Polyakov. But at that time, I was reluctant to accept the idea. So in my first draft, I made this point rather vague, and Joe forced me to make this point more explicitly in the paper. I also remember another comment of Joe. He told me, This project may not be the complete answer, but it is worthwhile to pursue. Well, he was actually very close to the answer. So this is a lesson I had. Take seriously what your teacher said. He might be correct. So probably I had better take firewall seriously.
Thanks, Makoto. Simeon?
No, you can't. No, you can't. So,
Do you need help?
No, I'm good.
All right.
I'm good. So, wow. I'd like to just say a few words about my interactions with Joe Polchinski and tie together some of the themes that we heard with a theory. So I'll just start out by saying if I discovered string theory and not physics but all the interesting stuff in physics by reading Joe Polchinski's papers on the internet. That is how I became interested in doing this stuff in the first place. I didn't want to work on physics or with an advisor. I wanted to come to Santa Barbara and work with Joe, and he was very, very nice to let me do that. So thank you for that. If I hadn't worked with Joe, I probably wouldn't have done physics at all. His papers were just so clear and profound. I mean, very easy to learn from, very lucid and really bringing out the important points, and you feel like you learned so much after you read them. And there are other nice people who write papers too, in the audience, and so obviously no invidious comparisons are meant here, but at least for the stage I was at, which was just an undergraduate, working in an experimental lab, basically blowing off my job to read papers on the internet, Joe's papers really stood out quite different. And so by reading his work in a lot of detail, I felt like I knew him, and his way of thinking very well before we even met. And then I came to Santa Barbara and actually worked with him. And so it was a little bit of a surprise. Joe was very different than I would have thought when I read the papers. And I do not mean to suggest that his ideas weren't clear and lucid, but the person was just somewhat different than I would have expected. I'll just say, he was very laissez-faire and liked to kind of, quote, Texan, libertarian nostrums from Ayn Rand and Robert Heinlein. well, I'll just take an so he was always telling me how there was no such thing as a free lunch, and I should take that as a guiding principle in looking for solutions in physics. But I think he was also implying something about my personal. No, okay. Maybe I was reading too much. Maybe I was reading too much into that. But he was very laissez-faire. Very laissez-faire. Yeah.
You had the misfortune to be my student at the time I was finishing my book.
I see.
I wasn't there a lot.
No. It was good. But the kind of guidance I got. We were working on a complicated and technical problem about the renormalization group, and of course I read his paper a dozen times, and other things. And I asked, so what's the best way to think about the renormalization group applied to gauge fields? And he thought about it for a second, and he said, read everything and come to your own conclusions. But what I found was that taking but from his papers, certainly, I learned that Joe's great intellectual strength was just taking ideas seriously. Starting out with what might have sounded like a glib-sounding idea that people would talk about, but then really taking it seriously enough and literally enough to develop it. I think this theme is sort of very familiar to people who've familiar with Joe's work with the Renormalization group, effective string theory that Makoto mentioned. Amps and of course D-brains as dynamical objects, taking these ideas with a greater degree of seriousness than other people might do, really added incredible depth, and this was something really important I think I learned from Joe. But as to what it was like working with Joe, or why it was like that, eventually I developed a theory of Joe. I developed a theory there was another Joe Polchinski, which I never observed directly, but I developed a theory because from things I learned from his students, from Djordje.
Oh, really?
Who told me about his coffee addiction, and I know that he loved to work out and ride his bike a lot. So I developed a theory that Joe must have a severe potassium deficiency. Because the symptoms of potassium deficiency are irritability, problems with memory and cognition, and then certain other neurological problems with coordination and stuff. Not that I ever observed any of this. This is of course the opposite of what Joe is like, very much the opposite. And then Makoto told me about Joe's banana habit. How he would be constantly consuming bananas every time they were together, and this was right after Joe came to Santa Barbara, right? I heard this in Kyoto and I didn't believe it, and then sure enough, I think the next day, Joe, you wandered by and I had some bananas, and you pointed and you said, "Do you mind if I take one of those bananas?" And then the whole theory came together. So when Joe and I would work together, as soon as he started to get any idea of what was going on, we would be confused for a while, and as soon as he would start to get any idea of what was going on, he would immediately kick me out of his office to work on it by himself without my having to watch. What was he doing in that office? What was going on? What was Joe's secret? Well, I inferred that Joe's secret is that he must be a voracious banana consumer. That was the only explanation that would tie together these disparate observations and inexplicable phenomena. So as a result, I talked to some of your other students, and as a birthday present, we wanted to present you with this. And so in testing my theory, I'm going to falsify one of yours and tell you, Joe, yes, there is such a thing as a free lunch.
All signed. All signed.
Yeah, I think I got everybody who's up here. If there are any students who have not signed, yeah, Jamie's on there. Anyway, so there is such a thing as a free lunch. Happy birthday, Joe.
Can we switch to the other computer? All right, we started with Rob, who was, I think, 5th of Joe's students in Austin. I'm 007. And we shared the same birthday, and we had the same advisor. And I wanted to sort of end up with some historical view and tell you about the fastest email exchange I had with Joe. I have to say that, well, we all know that he's a great scientist, but He's also an extremely nice person who always answers emails. And from me, he gets a lot of crazy papers and crazy questions, and he always answers them. But this was almost instantaneous. I thought he was violating causality. It happened when Rob's first student, Vishnu Djordje, became my first postdoc at Virginia Tech. And then we wondered during our spare time what our academic lineage was. Now we know that Joe studied with Professor Manderstam here. He was in the audience. And so this is the answer that I want to point to. But actually we made a guess. I made a guess based on some knowledge of history of physics that I knew that Stanley studied at Birmingham. And in Birmingham in the 1950s, the big professor was famous Rudolf Peierls. Now, I'm sure that all of you know that Rudolf Peierls studied with Werner Heisenberg. His name is not there. And so my inference was, I think Peierls was second of Heisenberg's students. First was Felix Bloch. And I said, like, well, okay, everyone knows that Heisenberg studied with Arnold Sommerfeld. And then Vishnu says, like, once you get to physicists who work with the mathematician, there are people who have worked out mathematical genealogy, American Mathematical Society, Clay, North Dakota State University, I think even St. Andrews. And indeed, Arnold Sommerfeld in Königsberg worked with the person who proved that pi was a transcendental number. His name was Lindemann. And he, in turn, worked with Felix Klein of Erlangen Program Fate. And Felix Klein worked Plicker and Lipschitz. Nima mentioned old algebraic geometry. Well, Plicker was a famous algebraic geometer of that old type. But he also worked in physics, vacuum tubes, and led to the discovery of the electron. And here was our surprise. And I think that's why we got this very fast answer from Joe. Because you see that one Gustav Peter de Jeune Dirichlet comes in the next line from Plicker and Lipschitz. And that was the original message that we sent. We said, Joe, no wonder that you discovered D-branes, because you're directly related to Dirichlet. But Joe, of course, is a person who worries about details. He's precise, he's clear. So he says, George, are you sure about this? I have to contact Stanley and see if he really, indeed, worked with Rudolf Peierls. And there was some exchange, and it took probably a couple of days. And we got those emails from Stanley Manderstam. And Stanley pointed out that, indeed, Peierls was the big professor there in Birmingham. But he didn't work with him. He actually worked with Dick Dalitz and Paul Matthews. Right, we all know them, Dalitz-Blott or Matthews Renormalization Group, QED, and all sorts of other things. They, in turn, studied, I guess, in Cambridge with Nicholas Kemmer. A lot of people learned old quantum field theory before QED, I think, including Freeman Dyson from Nicholas Kemmer, who was one of the pioneers of meson theory and all sorts of things. And he, in turn, studied with Gregor Wenzel and Wolfgang Pauli. Wolfgang Pauli being the TA of Werner Heisenberg. Can you imagine having Wolfgang Pauli for your TA? That must scar you for life. But here we come again to Arnold Sommerfeld, because both Wenzel and Pauli work with Arnold Sommerfeld. And so now we can go back and use our knowledge that Arnold Sommerfeld actually studied to be an applied mathematician or mathematical physicist. And then we get to this beautiful connection to Dirichlet again. So it's a beautiful story, even though some people would say, like, well, why do you care? After all, physicists are a small world network, right? There's always 6 degrees of separation between us, right? But it is nice, right, as a story, to realize that Joe, the inventor of D-branes, indeed was related to Dirichlet. And of course, if you go down, and I think Joe, you completed this. It was for Stanley's 80th birthday here at Santa Barbara. Well, you can find all these distinguished other mathematicians and physicists. Of course, at that time, there's distinct with theoretical physics and mathematics. There was no distinction, really. I never understood this connection because this goes all the way to Byzantium. Anyway, so my personal experience, apart from being interested in this historical connection, was Joe was always extremely tolerant. You could come up with the craziest idea, and he heard a lot of I remember, I think at some point we even talked about something that became matrix theory, but we never connected with deep brains. This was in 91, 92, I forget, as a natural, well, we read membrane papers and thought about generalizing matrix, but the old matrix model. But whatever idea, he would always, take it in stride, criticize it if he thought that it was too crazy, but he was always tolerant and open and let you do basically what you wanted. For me, that's a perfect advisor. So it was a privilege to work with you, Joe, and happy early birthday. And thank you very much for listening to this panel discussion.
So I guess I've learned a few things about myself. Some of which are true. I can't respond to every. So the whip, by the way, Nelia had a whip of her own. She actually gave me a whip as a graduation present, which I got a lot of use out of. I stopped using it in talks when I realized it actually scared the audience. I would crack the whip thinking I'd get a nice response, and there was silence. I realized I was scaring people. And a few years later, I had to simply put it away because I was misusing it in ways I won't mention. Anyway, that's all I should say. But working with students has been one of the great parts of my career. I'm pleased to say, with each of you, I've written papers that I'm quite proud of, and that were a great adventure to write. Usually involving some period of confusion and then some insight and a happy outcome. So, but it's very much I don't know where I would have gotten to without the experience of working with you all. Anyway, thank you. So I would like, so what they're setting, I think there's a video next. But maybe while they're setting it up, we could get some pictures of me with my students, including I have some current students, and my advisor, Stanley, is here. Stanley. And I have a grand student here. So maybe we could sort of get the whole 4 generations up here for some pictures. So thank you, everybody. Tom here also?